Before we get started, we'd like to thank our sponsors for making this event possible. Special thanks to our platinum sponsor, OLAS. OLAS enables everyone to own a share of AI, specifically autonomous agent economies. We're also excited to highlight our silver sponsors: NIA, empowering decentralized applications and blockchain ecosystems; Venice AI, a private and uncensored alternative to popular AI apps; Mira, unified AI infrastructure, secured by crypto; and Theric, the first on-chain multi-agent system. To learn more about all of our sponsors, check the description below and dive in. Enjoy the show.
Hey everyone, John from Delphi Ventures here. Today I'm excited to have Andrej, co-founder and CEO of Wynd Labs, core contributor to Grass Network. We're going to have a conversation with Andrej for our AI and crypto conference. Andrej, welcome. It's great to have you.
Hey, John. Thank you so much for having me here. I had a ton of fun at the last Delphi podcast that I did, and I've been looking forward to this.
Andrej, let's dive straight in. So you guys are building data layer for AI. You squarely fit into the intersection of crypto and AI. In your own words, how do you describe Grass? And could you share maybe some of your vision with the network?
So the biggest problem with AI today is the fact that good data for AI models, and specifically good knowledge for AI models, is very difficult to retrieve. And in order to solve this problem, companies are turning to very unethical methods because before Grass, they didn't really have a better solution. What I mean by that is a lot of companies today, they're hosting a ton of data that might not necessarily belong to them, but they want to monetize it in some way. So they make access to that knowledge very difficult for AI models that are trying to do useful things. And in order to get around these walled gardens, what companies are doing is sneaking software into free applications that you download, such as Roku TV screensavers or free VPNs. And once you've downloaded that software, they actually use your device and take advantage of the fact that it has a residential IP address and a regular looking device fingerprint. And they scrape petabytes of information on a daily basis using millions of people's computers around the world, and they don't pay them a penny for it. And usually people accept these things because they agree to a specific terms and conditions or privacy policy that, let's face it, none of us are reading. Now, what Grass aims to solve is both of these problems. The technical problem of being able to retrieve high quality data for AI models and actually making them useful. And secondly, the ethical problem. Companies shouldn't have to resort to these methods to go and make useful technology for the world. And what Grass allows you to do is actually opt into the network. So you get to take back a little bit of control. You download Grass on your device, and by downloading Grass, you're joining a network of millions of nodes around the world, which are being used to scrape, at the moment, 50 to 100 terabytes a day of data, which is then used to train AI models. And what you get in return for joining this network is probably more powerful than anything that a centralized company could ever offer. And that's network ownership.
Amazing. So I want to actually, I want to follow this up with a great piece I've read recently on Deepin. I don't know if you guys kind of describe Grass as Deepin necessarily, but I think it fits. It directly describes what was happening at Grass. So this post was from Nowhere and 0x Mac, authors from Compound VC, and in their own words, they describe quote unquote. They say Deepin specifically excels when at least one of the following is true. One, when it's hard for a centralized party to scale infrastructure. Two, when there's an opportunity to create greater efficiency in matching supply and demand. And three, when you can offer like competitive pricing because the network is using otherwise underutilized or idle resources. So I think Grass is like unique in that it checks all of these boxes. So it's one of those projects that clearly is stronger when executed through a decentralized network of millions of nodes as opposed to a centralized company. So I'd like for you to kind of walk us through on why that's the case specifically in Grass. I find that very interesting.
Well, when you're looking at decentralizing a system, one of the questions that is very obviously the most important question to ask yourself, but ironically ends up being overlooked in many, many cases, is why are you decentralizing this system in the first place? Now, when you're achieving a certain level of decentralization, you're creating a distributed system. So, regardless of what you're building, you need to include some sort of peer-to-peer component. And a few months ago, a pretty senior software engineer told me, I don't like peer-to-peer. I avoid peer-to-peer because when I hear peer-to-peer, that means bad. In most cases, that's true. I'd say in over 90% of cases, if you want to decentralize a system, you have to make a very important trade-off, which is sacrificing performance in order to gain something from decentralization. Now, if you're going to decentralize that system, you have to wonder, okay, why am I doing this in the first place? And is that problem that I'm solving more important than the loss in performance? Now, Grass is pretty unique, to your point, in that there's no way to do it in a centralized manner. Even if a Web 2 company wanted to build something like Grass, and like I mentioned earlier, they're doing very similar Frankenstein-y, unethical versions of what Grass is achieving. It's still a distributed system. So when we're looking at things like latency, there is no trade-off in performance. And because of that, Grass is capable of matching any Web 2 competitor both on price and on performance. Now, the other question, people don't really ask themselves very much, but I think they should, is who's the party that really benefits from decentralization in the first place? In our opinion, when you're looking at AI, if you're decentralizing most of the middleware components, it's very difficult to make the argument that you're actually doing something useful. In so many situations, you're just making the developer experience worse and then carrying that on to the end user. And if you're going to decentralize the system, it should be done at the end of the day to benefit users. Otherwise, you're wasting your time. Users are the most important thing in AI. And that's because they're the ones that basically built AI. Like AI wouldn't exist without the internet and the exabytes of data that exist on the internet that all these models were trained on in the first place. And if we're going to decentralize AI, it should be the net benefit for the people that put that information on the internet in the first place.
Could you maybe double down on why this is kind of not doable in a centralized way? Why you like by default need a distributed network for something like Grass to work in practice?
Well, if you want to go and scrape billions of rows of data from a small number of websites, you need a pretty big computer to do that. And in most cases, what a company will do if they want to achieve something like this is they'll host a huge server on AWS and then write a program that'll go and visit those websites and then download all the information from them. Now, what ends up happening is when they get to a certain level, that website, they want to create a walled garden because that's what benefits their corporation, regardless of what users care about. And they'll go and block that server because they see one single IP address and one device fingerprint that belongs to a massive server somewhere at a known AWS data center. And they'll block it very quickly. And after that, it's actually a lot of work, and it can get pretty expensive to go and do everything from scratch and try to rescrape this data. Now, you end up having an even bigger problem in the cases where you don't get blocked. And instead, the website that you're trying to scrape decides to engage in data poisoning. And this is becoming a problem that is increasingly relevant for AI, where companies detect a non-user device fingerprint or IP address, and they say, okay, well, that's an AI model. And even though that AI model might be serving some real person at the end of the day and helping them with their user experience and being a net benefit to this website, the website might go and further their own initiatives and say, hey, let's change this line of text to say something else. Let's change this price so that we can make the market less competitive and make it more to our advantage. So if you try doing this in a centralized manner, the only way to do it is, I guess, to call 10 million people, invite them all to one data center and plug their phones in and all have separate data plans. And obviously that's not very realistic. We're a lot better off with a peer-to-peer system.
Yeah, definitely doesn't sound realistic. All right. So I want to get your perspective on like the future of data for AI in general. It's a like fundamentally very crucial part. AI is just a combination of compute and data. So thinking about the role of like data in AI from and now and into the future, what are some forward-looking statements that you can make with high confidence? Some predictions, let's say, that you think that like some factors that you think will remain to be as true as they are today, and what are some parts of it that are less clear to you that may be subject to change? Yeah, would love to get your perspective on both of those.
So I don't have a clue what the world's going to look like 5 years from now, 1 year from now, maybe even next week. And to your point, what we like to focus on is how's the world not going to change? And one thing that's going to remain the same in the next 5 years, 10 years, or maybe our entire lifetimes is the fact that new information will appear on the internet, regardless of whether it's written by a human or a machine. And AI models will need access to that new information. Now, we're starting to see a pretty interesting phenomenon across AI, where for the last 2 years, all the focus was on scaling. And people are looking at scaling properties and emergent properties and saying, hey, if we 10x the parameters and 10x the parameters and keep doing that, maybe we'll achieve some new emergent property. And maybe after like 2 or 3 emergent properties, it'll be AGI. So we just got to keep making these models bigger, keep getting more data, whether it's synthetic or not, and just try to see if we can break that barrier. And we're quickly beginning to realize the limitations of transformer-based models for this type of thinking, as at least as far as text is concerned. So large language models, like they're amazing at interpolation and summarization, but increasing the scale of these models hasn't necessarily shown to improve any sort of language reasoning ability. And language reasoning ability, it seems, has more or less tapped out. And this is further evidenced by the fact that OpenAI they basically confirmed that GPT-4 wasn't actually it wasn't actually a trillion parameter model, but rather a combination of 200 billion parameter models. So it was a mixture of experts type of model is what they call it. So anyway, we look back to your question about what might change, what's not going to change. Well, what's changing today is the fact that these companies stopped looking at scaling, and instead they're looking at how do we change things algorithmically? How do we change the training process so that we can build smaller, more performant, and actually usable models? So all these like huge corpuses of data, they're quickly becoming actually pretty commoditized as far as text data is concerned. So you can do a huge web crawl, and that data after a week or after a month or after a year might not be super valuable. However, the second it hits the internet, the second it appears, it contains a lot of value. And the half-life of that value is very short. So it's incredibly important that a system exists that's able to scrape that data in real time and supplement that knowledge to AI models. So the way this is being done today is actually through internet scale web crawls. And there are only two companies that are capable of achieving an internet scale web crawl. And by doing that, they're monopolizing basically access to knowledge that should be available to the world. And by acting as the funnel or the gatekeeper to that knowledge, they're actually capable of producing adverse outcomes to the future of society. And that's an important problem for us to solve. And that's where Grass is really focusing these days with live context retrieval, which is a new technology that Grass is building that you can think of as a way to plug any model into the internet. And by using the Grass infrastructure, that model suddenly has online capability. And when an LCR launches, it'll be the only unbiased way for any model in the world to actually read the internet in real time and inform answers in real time. Now, I did say that scaling properties have more or less saturated when it comes to language models, but this is far from the case with multimodal data. Now, for those that aren't familiar, multimodal data means things like video and audio, and even genetic data, for instance, which a lot of people are doing really cool things with transformers. We haven't seen anything near saturation yet. So it's an incredibly exciting and innovative area as far as data is concerned right now. And it's actually driving a pretty large percentage of the demand on the Grass network right now. So the way we see the demand for data right now is over the next couple of years, just because of the sheer size of multimodal data and its sheer scarcity, around 90% of demand for these types of networks to scrape data is going to be driven towards multimodal data sets. But longer term, where we see all the value accruing to this network is in real-time access to information.
And just to make sure I understand you correctly, when you mean real-time access to information, like I kind of want to unpack that. Like, so there's a whole sort of supply side here, sourcing all the data, but then on the demand side, this data is high in demand for AI use cases. But I'm curious, like, what specifically do you think Grass network data, the data that is scrapes, will be used? Will it be used for pre-training? Will it be used for fine-tuning, for inference, or other? We would appreciate some more information there.
Yeah, so if you asked me that question a month ago, I would say 100% inference. But some of the recent developments from OpenAI and DeepMind have been quite interesting because there's this renewed focus on reinforcement learning. And what I mean by reinforcement learning is when during the training process, instead of just generating a bunch of outputs, the model kind of acts recursively. It repeats things. It looks back on what it produced and says, was this right or not? And it has a scoring mechanism to determine whether or not it was right. Now, anytime you're building a reinforcement learning loop, you need a source of truth. Otherwise, it's useless. You need something to say, hey, this was done properly, or this was done incorrectly. And one of my favorite AI papers of all time, it was the Alice in Wonderland paper that was produced by Lion a few months ago. It showed us that all these top models in the world, like they've been overtrained on a set of problems that made it seem like they had this superhuman reasoning ability. And if you give them very simple logic puzzles, they end up failing and performing worse than someone in grade school. And these are models that are marketed as PhD level reasoning. However, what a lot of researchers found was they took the same models, gave it those reasoning problems, and then plugged the model into the internet using one of the existing web crawls. And all of a sudden, it was able to solve these problems. Now, it wasn't able to solve these problems because it was suddenly reasoning. But it was able to solve these problems because it was able to go and fetch very specifically a problem that someone else had posed and someone else had answered on the internet, somewhere very random or hard to find in the general data set that the model was originally trained on. And then using that information, it can give you an answer. And what they found was by plugging a model into the internet, you actually give it the impression of reasoning. Now, this was a huge deal for us because when you're looking at LCR, what LCR is capable of doing is fetching any data from the internet, ensuring that it's the most relevant to the prompt or input or whatever is prompting in the first place, and then matching it and sending it to the model. Now, during the reinforcement training loop, this is a beautiful source of truth. And this was really exciting for us. These new developments and the push for reasoning models, it's a huge deal for Grass because all of a sudden LCR becomes not just something that makes inference useful, but rather also something that can supercharge the training process. And to your other question about very specific use cases, they're infinite. Literally anything we do in our daily life, like any productivity-based action that we perform, it requires some new information from the internet that might not necessarily be present in an existing AI model. So let's say you want to go and book a flight. Well, you can go and ask an AI model to go and find you the best prices online or do some actions for you. But it won't be able to do the whole process for you start to finish. It won't be able to go and book everything and give you a bunch of options based on your preferences and then book it. And that's because these models are getting honeypotted by the websites that host that information. So if you ask, one of the top LLMs, hey, can you go and book this for me, or can you go and do this for me? It ends up getting blocked by that website. And it's going to refuse to actually do it for you because the developers that built that model, they know, and they put those guardrails there. Now, if that model is plugged into Grass, that's something those developers wouldn't have to worry about. And all of a sudden, you've unlocked a multi-billion-dollar industry that previously was not able to use LLMs. So in a sense, you can think of anything that you do on the internet or anything that requires information in real time from the internet. Most of those things right now are blocking the product market fit of AI. And live context retrieval, once Grass launches it, will remove that block.
Once Grass launches it, is there an ETA on that? Or how soon is it? Can we have an announcement of an announcement? What can we hear on this?
Well, some of the alpha tests are pretty incredible. In a few hours, Grass is capable of retrieving 25 million rows of Reddit data with almost 100% accuracy based on certain prompts and certain parameters. Now, what we want LCR to work on longer term is the entire internet and not just one specific domain that's updating in real time. And when we launch the beta of LCR, the way we're actually thinking of launching it is a way that allows Grass users to interact with it. So without giving away too much right now, because I do want to save the excitement for the announcement, we want to give anyone who's been contributing to the Grass network by connecting their device and their idle resources a way to go and see what it's capable of firsthand. And that's something that we're building for them right now.
Very exciting. Very exciting. Andrej, I'm curious, when you which one do you think better describes Grass? Would you describe Grass as something like they will come if you build type of play, where it's a reactive network that continuously scrapes data regardless of if there's a demand from an AI company at that point in time? Or is it more of a proactive network that, let's say, first gets commissioned by an AI company to scrape certain piece of data and then go ahead and consumes the bandwidth resources to scrape that data?
At the moment, the way this decision-making process works is we have a certain view on what data is the most important for AI, or where is the highest demand for AI, and then we work with a number of fairly influential industry partners, especially in the AI field, and talk to them, and then we determine a decision from there. So to answer your question, it's a bit of both. For a large part, like we try our best to anticipate where the demand's going to be. But at the end of the day, final decisions are always driven by real demand. Now, the reason that this needs to be done today is because grass isn't large enough yet to crawl the entire internet. Once that's possible, there won't be a need to go and anticipate which data sources are going to be the most valuable for AI and which ones aren't. But for the time being, this is something that we're able to do by coordinating and cooperating with some of the top research labs and corporations in the AI sector. And when it comes to LCR, though, the point of LCR isn't necessarily to just scrape data sets and then sell data sets as sort of the service business. The point of LCR is you can think of it as a piece of infrastructure. You plug a model into it, and then based on what that model needs, the network will scrape it. So that ends up being a much more dynamic demand profile, which updates in real time, just like the data that it's fetching. So if suddenly there's a newfound need for a certain data source, LCR would automatically cover that, and that's something that contributors to the network wouldn't even have to worry about.
Interesting. When you talk to these AI companies, do you ever get a pushback from the fact that like this is using like crypto technology? Like the crypto has sometimes a branding problem, right? Like I've been hearing like not many AI people like crypto necessarily. So I'm curious, like your experience, what have you been seeing, hearing from those conversations?
Crypto certainly has a branding problem today. I'd actually take it a step further, and maybe I'll say something that might be seen as controversial here. But I think the term Web3 is largely a misnomer when it's being used to refer to crypto. What I mean by that is when we're looking at the progression of the internet from Web 1 to Web 2, we saw the internet go from somewhere open with millions of URLs that people can go and visit and millions of links that people can click and explore things, to a more closed system, like a smaller funnel with more people trying to fit through it. And what I mean by that is a small number of apps that everyone in the world is using to access the internet. So you go from, visiting tens of websites on a daily basis to one or two apps on a daily basis, but you end up spending a lot more time on the internet. So that was Web 1 to Web 2. Like the small number of very big companies created apps that became your view or like your gateway into the internet, and they got to control that, and that's very, very powerful. Now from Web 2 to Web 3, to say that Web 3 is crypto, I don't think that's necessarily fair to AI. In my opinion, AI is the real Web3, because what AI is trying to do right now is make the internet even more closed. So it's just a progression of what we've been seeing all along, where instead of interacting with a small number of applications, you spend even more time on the internet and you interact with one LLM that controls all of your inputs that are going into the internet and gets to control your view of the internet. And this is kind of a scary thing if it's in the wrong hands or if it's implemented the wrong way. And where crypto plays into that is as a technology that enables this to be done in a more open manner. So we have a chance here right now as we transition from Web 2 of mobile apps and social media to Web 3 of AI to use crypto to do the right thing. And, when we talk to AI labs and when we tell them, look, this is the technology that we're building, this is why it exists, and this is why people are downloading this application. People are very understanding of the fact that blockchain is a very important technology to make sure that this is being done properly. Because when we explain the problem that we're solving, people quickly realize, hold on, this is actually impossible to implement fairly without crypto. But yeah, I mean, to your point, in many ways, crypto has lost its way and deviated from its original vision. But I'm pretty optimistic for the future. We're starting to see some really exciting things come up. So, yeah.
Very cool. Okay. I want to switch gears a bit to talk a bit about the scope of kind of work at Grass Network. So we talked about data sourcing, but I know there's a whole like downstream of tasks that Grass Network does in order to actually like transform that raw data that it scrapes into a finished product that can be served to AI companies. Could you describe in detail what happens there?
Yeah. So when you scrape data from the internet, in its really raw format, it's filled with these ugly HTML elements. So if you ever go to a website, you right click and click inspect element. And if you've never worked with front end web development, you kind of see this really ugly code almost. And it's kind of difficult to discern what's going on and make sense of it. So when you're scraping tons and tons of web data, that needs to be cleaned up. And not only does it need to be cleaned up, but it needs to be restructured into a format that LLMs can read. Now, today, this is being done on centralized servers for the purpose of efficiency. And some of these workloads are pretty heavy, so they can't be run on people's devices on the edge. Now, that is actually part of the reason why Grass is working on a hardware device, because we understand that there are millions of users on the Grass network today who want to contribute in a more significant capacity. And we want to be able to give them the tools to do so and allow them to help grow the Grass network by running these heavier hardware nodes that are capable of some of these downstream data tasks in addition to some of the other scraping workloads. And one of the other things that you mentioned was data labeling. We're starting to see. I think it's very interesting problem space today because it became saturated and commoditized very quickly, and it's something that we knew was going to happen, but I don't think many of us expected it to happen this quickly. And now, when I say saturated and commoditized, I'm not referring to like expert labeling. I think that's something that there's certainly a world for and like a need for, and there's probably a scarcity. What I'm referring to is crowdsourced labeling. But yeah, I mean, right now for some of the multimodal data sets that Grass is working on, and I don't want to reveal too much because there's going to be an announcement about this, and I think it'll be very exciting when it comes out. But Grass is running some labeling tasks on some of these multimodal data sets, so pretty excited for everyone to see that.
Very interesting. To your earlier point, though, I want to understand a bit better. Your point there was that in text data labeling, you think will get commoditized over time or unsaturated. Is that a right understanding, or am I misinterpreting what you said?
I think crowdsourced labeling, and generally with text, yeah. Like as far as text models are concerned, we've reached a certain point now where you're achieving diminishing returns. Language models are capable of reasoning. If you want them to do something in a specific style, it isn't that much of a leap to go and fine tune a small model to do something very specific for you. And labeling tons of text data, you can help fine tune things like emotions today. But where the real needs are for this type of work is actually in multimodal, because those models are far from where text models are today. So I wouldn't necessarily say that, that's something that's over or that isn't necessary anymore. It's just that there are much higher needs in other areas, and that there are, I guess, low touch ways of solving these problems when it comes to text.
Yeah, let's talk a bit about the node types in the network. I know like currently vast majority of nodes are like accessing data through they just download a browser extension, and that's kind of how they access Grass network. And then I also know that, and then you mentioned this earlier, you have a plan with offering like an alternative and having like power nodes, right? With the Grass box. What could you share with us with that node type, and what's kind of the role of it in the network, and how it will enhance Grass?
The best way to join the network today is to download the desktop node. Because not only does it use a lot less resources on your computer, so like a lot less memory, but it's capable of scraping about 10 times more information. And the reason for that is because when you're running something in a Chrome browser, you end up being quite limited by Chrome eating up tons of memory in the first place, running all these other background processes, and also limiting the types of connections you can make, like at which network level you're connecting. So if you haven't joined Grass yet, or if you have joined Grass but are only running a Chrome extension, I highly recommend that you try out the desktop node. It's the best way to join the network today. But yeah, as I mentioned earlier, we do want to give people the ability to be power users if they want. And that's why we're working on this hardware device. And I don't want to give away too much about what's exactly happening under the hood, but I have hinted at it. The TLDR is there will be an ability to run other types of edge compute workloads in addition to the scraping that's already happening.
Andrej, thanks for joining. I think your all your answers was great. I've learned a ton in this podcast. I like, as we finalizing this, I want to ask you if you have any closing remarks or any announcements you'd like to share on Grass. Yeah.
I suppose a closing remark I'll make is that for decades now, a very small number of companies have been commoditizing our curiosity. And we're starting to feel the downstream effects and the impact of that. And they're quite negative. And I think it's safe to say that a pretty large percentage of the world now is sick of this. And I think it's time that we all do the right thing. And that being said, if you're watching this and you haven't joined Grass, I encourage you to touch Grass, join Grass, and maybe even join the community and say hi. We have a Discord server with around 500,000 people, and it's always buzzing. People are speaking in over 100 different languages, and they're all over the world from all kinds of different backgrounds, and it's a lot of fun in there. So, and outside of that, John, thank you once again for having me here. This was a blast.
Thanks, Andrej.